This line shows the predictor variable, x, with 5 data points ranging from 1 to 5. I'll use this data to explain isotonic regression. This line tells us what the isotonic regression model predicted for each value of x. These are the results of our model. These are the model's predictions. Notice that the values generally increase, but there's a plateau, and I'll highlight the significance later. I'm analyzing a model using a technique called isotonic regression. It's a method for finding the best fit line to data, but with a special restriction. The line must be monotonic. This line refers to the whole collection of data points I'm working with, both the input values x and the model's prediction for each input, y_fit. The specific type of statistical model being used is called an isotonic regression model. It's designed to find the best monotonic fit to data. I'll show you how to interpret the results. This line poses the quiz question about the properties of the isotonic regression model fit based on the given data. This line sets the context of the multiple choice question I must answer using the data presented. One of the possible answers, the regression line always goes up. I'll check the data to see if this holds true. Another option, the regression line either goes up or stays flat, but it never goes down. Let's investigate. A third possibility, let's analyze the model output to determine whether this is accurate. The final option, the regression line remains flat for some data points. I'll examine the data and explain my decision. I'm analyzing a model called isotonic regression. This model finds the best fit to data, but with a special rule. The fit must always go up or always go down. It can't go up and then down. Think of it like climbing a hill. You can go straight up, or maybe take some pauses on a flat section, but you can't go down. This analysis helps me understand how well this model represents the relationship between input, x, and output, y. I have a dataset to work with. It includes inputs, x, and the model's corresponding outputs, y_fit. The model has given me these outputs for each input, and I'm trying to understand what they mean. This dataset is the basis of the analysis. These are the input values for my model, in order. I am giving the model this data to predict and then compare results to understand its effectiveness. These are the results from my isotonic regression model. The model predicted 1.2 when given input 1, 1.8 when given 2, and so on. Notice that for input 3 and 4, the model's output is the same. I'm using a specific type of regression model called isotonic regression. It's designed to find a relationship between input and output that's always increasing or always decreasing. This is different from regular regression, which can go up and down. I applied the isotonic regression model to my dataset. This involves using an algorithm to find the best monotonic fit. This means that the line of best fit will always move in one direction, increasing or decreasing. The y_fit values are my model's predictions. I'm analyzing these predictions to understand the model's behavior and characteristics. I'm answering a multiple choice question based on the model's results. The question assesses my understanding of isotonic regression and its properties. These are the options in a multiple choice question testing my understanding of the model's properties. I'm choosing the correct options. We're investigating a specific isotonic regression analysis. We'll examine the results to determine if certain properties hold true. The dataset includes a predictor variable, x, and its corresponding fitted values from an isotonic regression, y_fit. These are the input values for the isotonic regression model. They are simply the numbers 1 through 5. These are the output values predicted by the isotonic regression model for each input value in x. Note that the third and fourth values are identical, 2.5. I'm using scikit-learn's isotonicregression to model a monotonic relationship, one that's either always increasing or always decreasing. This model finds the best fit within this constraint. This model doesn't have to be strictly increasing, it can have flat sections. Let's check whether there's a plateau in y_fit. A plateau would mean that y_fit values remain constant for some consecutive inputs. Looking at y_fit, I can see the values 2.5 repeat. This confirms a plateau. I'll check if the y_fit values always increase or stay the same as the x values increase. In this case, the values never decrease, they either increase or stay the same. Therefore, the regression is monotonic increasing. Now I'm checking if y_fit is strictly increasing, meaning the values always increase. The presence of the plateau, 2 consecutive 2.5 values, means it's not strictly increasing. To evaluate a perfect fit, I need the original y values that the isotonic regression is trying to approximate. This data is not available here, so I can't definitively say whether it's a perfect fit. Isotonic regression strives for a monotonic fit. It doesn't guarantee a perfect fit to all data points. Based on my analysis of the y_fit values, I can determine which statements about the isotonic regression are true or false. I'm using the input data x equals as my predictor variable. This is the data I'm using to test my model. I'm using Sklearn's isotonic to build my model. This model helps me find the best fit among those that are monotonic, either always increasing or always decreasing. After fitting the model, I get these predicted values. YFIT equals. These are the model's predictions based on the input data. I'm asking you which of the multiple choice answers are correct based on my model's predictions. Let's analyze the results. This statement means that the values in YFIT should always increase as the values in X increase. Here, the values in YFIT should either increase or stay the same as the values in X increase. They shouldn't decrease. This tests whether the predicted values perfectly match the original, unseen, response variables. This checks if there is a range of input values where the output is constant. In other words, is there a flat area in the predictions? I analyze data using a method called isotonic regression. This method helps me find the best fit for a relationship between two things, but it only works if the relationship increases or decreases steadily. It's like finding the smoothest uphill or downhill path, even if the data is a bit bumpy. This is my input data. It's a simple list of numbers, from 1 to 5. Think of it as representing different levels of something, like the amount of fertilizer used, or the hours of studying. This refers to the complete set of data points I'm working with, which includes both the input, x, and the output, y_fit. Think of it as the whole picture I'm studying. This is the specific type of mathematical model I'm using to describe the relationship between my input and output. It's based on the concept of monotonicity. This is the process where I apply my isotonic regression model to my dataset to find the best fitting relationship between my input data, x, and the actual measured outputs. Here are the answers or outputs of my model fitting process. The output, y_fit, reflects the model's predictions for the given input, x. The question tests my understanding of what my model predicts and whether various claims about the predicted values are accurate. This statement checks if the predictions from my model always increase or stay the same as my input increases. It does not require a strict continuous increase but only a non-decreasing pattern. This statement checks if there are any sections where my model's predictions stay the same even as my input increases. A plateau means a period of constant value in my output predictions. This statement checks if my model's predictions exactly match the actual measured values. This statement checks if my model's predictions always increase continuously as my input increases. It is stricter than monotonic increasing as it disallows any plateau in prediction. These are the predictions from my isotonic regression model. For each value in x, my input, I get a corresponding value in y_fit, my prediction. Notice that the values generally increase but there's a plateau at 2.5. This line shows the input data, x, which represents the predictor variable. I see 5 data points, ranging from 1 to 5. This line displays the corresponding fitted values, YFIT, produced by the isotonic regression model. Notice that each YFIT value corresponds to an x value, and I observe a plateau at 2.5. This describes the type of model used. Isotonic regression finds the best fit that is either always increasing or always decreasing, ensuring monotonicity. This simply labels the values in the next line. They are the model's predictions. Again, these are the fitted values, the model's predictions that we carefully examine to answer the quiz questions. This is one of the multiple choice options that we must analyze. The question asks whether the model has identified a plateau in the data using the provided YFIT values. This is the overall topic. I am analyzing the results of an isotonic regression. This line describes the data I will use for my analysis.